class on analytical geometry. In the previous class, we have studied what is a coordinate system, how to draw a coordinate system, and how to mark points on a coordinate system, especially a two-dimensional coordinate system. Today, we will analyze what is distance formula. Distance, in particular, it means distance between 2 points, 2 places, or 2 objects. We are interested in between 2 points. Suppose P of x1, y1 and Q of x2, y2 are 2 points in the xy plane, then the distance between P and Q is given by PQ is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. That means if 2 points P and Q are given, the coordinates of P are x1, y1, the coordinates of Q are x2, y2. Then to measure the distance between these 2 points, that is how much distance is from P to Q, the formula we use is square root of x2 minus x1 whole square, the x coordinate of the second point minus the x coordinate of the first point whole square plus y2 minus y1 whole square, y coordinate of the second point minus the y coordinate of the first point whole square, then I take a square root. If P and Q are the points, then the distance I write it as PQ. Therefore, this is the formula we have to calculate the distance between 2 points. Keeping this distance formula, we can study many more things in analytical geometry. We'll see them one by one. Applications of distance formula. If A, B, C are any 3 points in the plane, I take 3 points A, B and C, then anywhere I take on a paper, 3 points on a paper, that means I can draw them however I want, any 3 points. Depending on the distance between the points, I can tell whether the points you have marked form a triangle, they lie in the same line, they form a square or anything. Because we have 3 points, the square does not come here. Simply if I mark 3 points on a paper, depending on the distance between the 3 points, I can tell whether they all lie in a straight line or they form a triangle or not. Okay. So the first application. If AB plus BC is equal to AC, then the 3 points are collinear. If AB plus BC is equal to AC. ABC are 3 points. The distance from A to B plus the distance from B to C is same as the distance from A to C. That means they all points lie on the same line, or they are called collinear points. They lie on the same line. If AB plus BC is greater than AC, then the 3 points form a triangle. If they are equal, then they are on the same line. If they are not equal, if it is greater than AC, A to B plus B to C is greater than A to C, then the 3 points form a triangle. Basically, we are measuring the distance between the 3 points in the form AB, BC and AC. These three distances we will be measuring. If two sides are equal, then they form an isosceles triangle. What do you mean by an isosceles triangle? Triangle means it has three sides. In that triangle, if two sides are equal, then we say that the triangle is an isosceles triangle. Therefore, if I measure the three distances out of which two distances will be equal, then they form an isosceles triangle. If all the three distances are equal, then they form an equilateral triangle. We have studied different types of triangle: acute angle triangle, isosceles triangle, equilateral triangle. Equilateral means all the sides are equal. Therefore, if AB equal to BC equal to CA, then they form an equilateral triangle. If Pythagoras theorem is satisfied, then the points form a right angle triangle. What is Pythagoras theorem? AB square plus BC square is equal to AC square. If I don't take the square, then they become collinear. If I take the square, AB square plus BC square equal to AC square, then they form a right angle triangle. What do you mean by a right angle triangle? One angle in the triangle is 90 degree. Then we say that the triangle is a right angle triangle. Then the second application is if we are given 4 points. If ABCD are 4 points, no 3 points are collinear. Using distance formula and the following properties, we can determine the type of quadrilateral formed. If 4 points are given to us and out of which 3 are not on the same line. Okay, then using the following observations, we can tell what type of quadrilateral is formed. Quadrilateral means it is a four-sided figure. If all sides are equal and diagonals are also equal, then the quadrilateral formed is a square. Okay. So what do you mean by diagonals? If I draw a image like this, so four sides are equal, then we say that it is a square. The line joining the opposite sides, it is called as diagonal. If A, B, C, D are four sides of a square, then this corner, one corner to another corner, top corner to the bottom corner, those lines are called as diagonals. If all sides are equal, also diagonals are equal, then the quadrilateral form a square. If opposite sides are equal and diagonals are equal, then it forms a rectangle. We know that what is a rectangle? Opposite sides are equal. Then it forms a rectangle. Also, diagonals are equal in a rectangle. What do you mean by a rhombus? What do you mean by a rhombus? Rhombus is nothing but okay, I hope we can mark something. Uh, I hope you know the rhombus. Rhombus is nothing well like a kite shape. Okay, kite shaped figure, and in rhombus, if you measure the kite in the rhombus, then four sides will be same, but what we write, the one line will be on the line joining the opposite corners, one will be long and one will be short. Therefore, rhombus, all sides are equal and diagonals are not equal. I think that text is missed out over here. Diagonals are not equal. Parallelogram, opposite sides are equal and diagonals are unequal. Therefore, there is a difference between rectangle and a parallelogram. Rectangle means opposite sides are equal. Parallelogram also means opposite sides are equal. But in rectangle, diagonals are equal. But in parallelogram, diagonals are not equal. Square, all sides are equal. Rhombus, all sides are equal. But in square, diagonals are equal. But in rhombus, diagonals are not equal. We'll move on to the problems. Keeping everything, we will see how to solve a few problems. Simplest one, find the distance between the points A 5 minus 12 and B 9 minus 9. Okay. So A is this point, B is this point. So I'll write the point A 5 minus 12, B is 9 minus 9. First point, the coordinates we'll call as x1, y1. Second point, we'll call it as x2, y2. And by distance formula, distance from A to B is nothing but square root of x2 minus x1 whole square plus y2 minus y1 square. So this is nothing but square root of what is x2, x coordinate of second one 9 minus x coordinate of first one 9 minus 5 whole square plus y coordinate of second one minus 9 minus, again there is a negative sign in the coordinate, therefore minus of minus 12 whole square. 9 minus 5 is 4, 4 square plus minus 9, minus into minus becomes plus 12 whole square. Square root of 4 square is 16. This becomes 12 minus 9 is 3, therefore 3 square. Therefore root of 16 plus 9, that is root 25, which is 5 units. The distance are given between 2 points, therefore we don't know it is in meter, centimeter, feet, inch, whatever might be. So usually we denote it as some units, maybe centimeter, meter, kilometer, whatever it is, some units we will write. We'll write it as 5 units. Find the distance between the following pairs. I have given few simple points. The same way what we have learnt now, you can try to solve the distance formula. Fourth one, we will go through the few different points mn and n comma n. These are the 2 points given to us. First point is n comma n. Second point is n comma n. Therefore, this is x1 y1. This is x2 y2. By using distance formula, I'll call the first point as a. We will call the second point as b. So AB is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. What is x2? X coordinate of the second one, n minus n whole square plus y coordinates m minus n whole square. Then square root of n minus n. We'll use the a minus b whole square formula. A minus b whole square equal to a square plus b square minus 2ab. So a minus b whole square is equal to a square, that is n square, plus b square, that is n square, minus 2 into first one into second one, 2 into n plus. Similarly, formula here, first one square plus second one square minus 2 times first one into second one. Then we will see n square becomes 2n square, m square becomes 2m square, minus 2mn becomes minus 4mn. So that this is square root of 2, I can take common, m square plus n square minus 2mn. Here, which property we have used? We have used a property of square roots. Root of a into b can be written as root of a into root of b. Therefore, root of 2 into this term can be written as root of 2 into root of this term separate. So, root 2 into, this is again of the form. What is this? We have written here, right? N square plus n square minus 2mn. That is nothing but m minus n whole square. Therefore, this is again m minus n whole square. Square root and square gets cancelled. So what is left is modulus of n minus n. It may be positive or it may be negative. Therefore, we write it as modulus of n minus n. Usually root of something we write it as plus or minus. Instead of that, I'll write it as modulus of n minus n. Similarly, the fifth problem, the first point is x minus y, comma y minus x. Second point is x plus y, comma x plus y. A little tricky one, not tricky one exactly. You should be careful with x and y. You can apply the distance formula. We'll call this point as a, call this point as b. Then you can directly apply the distance formula. Little applications of distance formula. If the distance between the points 3, minus 2 and minus 1, a is 5 units, find the value of a. Already the distance is given, you will have to find a point now. If the distance between this point 3, minus 2 and minus 1, a, it is given to be 5 units, find the value of a. So the first point we will call it as a, that is 3, minus 2. Second point we will call it as b, that is minus 1, a. Already the distance between them, that is AB, is given to be 5 units. So we will apply the distance formula, but this time we know the distance. So I will apply the distance formula, x1 y1, x2 y2, that becomes square root of x2 minus x1, that is minus 1 minus 3 whole square plus a minus of minus 2 whole square. So minus 1 minus 3 becomes minus 4 whole square plus a minus of minus comes plus a plus 2 whole square. Okay, I will keep it now. This part I don't consider now. Given that the distance is already equal to 5, therefore AB is equal to 5. So left hand side is 5. 5 is equal to this term. 5 is equal to minus 4 whole square is 16. Therefore 5 is equal to this term. Because I have a square root and it does not look nice, therefore that square root I will square on both sides, so that square and square root gets cancelled on the right hand side. So 5 square is equal to 16 plus a plus 2 whole square. 5 square is 25, 16 plus a plus 2 whole square. Then a plus 2 whole square, I will keep it as it is, 16, I will shift to the other side, becomes 25 minus 16, that is equal to 9. or a plus 2. Now I will take the square root. Square root and square gets cancelled. This becomes square root of 9 plus or minus square root of 9. So a plus 2 is equal to plus or minus root 9, or a plus 2 is plus or minus root 9 is 3. So a will be equal to, if I take this plus 2, that side it becomes minus 2. So a is equal to plus or minus 3 minus 2. Now these are two numbers, plus 3 and minus 3. If I take plus 3 here, then it becomes a is equal to plus 3 minus 2. Or if I take minus 3 here, this becomes a is equal to minus 3 plus 2. Therefore, a is equal to 3 minus 2, 1, or a is equal to minus 5. Therefore, a can take any of these values. You'll have to find the value of a, and we have found out the value of. Now, this is one more kind of problem. Find the point on the x-axis which is equidistant from 7, 6 and minus 3, 4. Find the point on the x-axis which is equidistant from this point and this point. That means I already have 2 points. I have to find a point on the x-axis which is at the same distance from these 2 points. Okay. So first I will take this point as A, this point as B. We require a point on the x-axis. We have done this in the last class. X-axis alone point bekunte hedadre its y coordinate will be 0. Therefore, let the required point be P of x, 0. P is the point what I want now. Given that the distance of this point is same from the 2 points, okay, therefore first point is A, therefore AP will be same as PP. What we had, P is the required point, and what is given to us, the point is equidistant from these 2 points. Therefore, if I call the points A, B and P, then the distance of P from A is same as distance from P to B. Therefore, AP will be same as BP. Using the distance formula, once for AP, once for BP. For AP, this is the distance formula. For BP, this is the distance formula. So what is AP? X minus 7 whole square plus 0 minus 6 whole square, taking the square root. What is BP? X minus of minus 3 whole square plus 0 minus 4 whole square, taking the square root. Simplify, squaring on both sides. I have this square root is there. Therefore, I have to get rid of that square root. I will square on both sides, which will give me x minus 7 whole square plus 36 is equal to x plus 3 whole square plus 16. This again I will apply a minus b whole square formula here. Here a plus b whole square formula. A square plus b square minus 2 into x into 7 is 14x plus 36 equal to a plus b whole square. A square plus b square plus 2 into x into 3, that is 6x plus 16. Rearrange everything. Keep x square and x square gets cancelled on both sides. Minus 14x, 49 plus 36 is 85. Here x square has already got cancelled. 6x plus 9 plus 16 is 25. Simplify everything, you'll get the value of x as equal to 3. And what does this x give us? X is the first coordinate of the required point. So what is the point? X value, I have got it as equal to 3. Therefore, the required point on the x-axis is 3, 0. Similarly, there is another problem. Find the point on the y-axis which is equidistant from these 2 points. Now, I think we have become intelligent. What about finding a point on the y-axis? X-axis means it is of the form x, 0. Y-axis means the point will be of the form 0, y. 0, x is also fine, but because we want it on the y-axis, we will take it as the required point is 0, y. I have simply given you the hint, and also the answer is given to you. You can solve this, and if any questions, you can get back to me. Now, the second round of applications. I have 3 points given to me. Prove that the points 3, 1, 4, minus 1 and 1, 5 are collinear. And what did we do when we have to show that it is collinear? We'll name them as A, B, C. Collinear means AB plus BC must be equal to AC. It need not be the same way always. Sum of any two distances must be equal to the third, because A, B, C need not be in the same row like this. A here, C in between, B might be this side, or C, B and A might be in between B and C. Therefore, to show that it is collinear, we will find the distance between all the three, and sum of 2 must be equal to some third one. AB plus BC ಅಂತಾನೆ ಆಗಬೇಕು ಅಂತಿಲ್ಲ. I can do this as AB plus BC equal to AC ಬಂದರೂ ಕೂಡ ಅದು collinear. Otherwise, if I get AB plus AC equal to BC, that is also collinear. But I should have sum of two distances must be equal to the third one, any two distances. So we will find all the possible distances. I have found AB, BC and AC. I think you can apply the distance formula because we have already revised many times now. Distance formula. AB means 4 minus 3 whole square plus minus 1 whole square, and take the square root. Simplify, we have got it as equal to root 5 units. BC is nothing but the distance between these 2 points. BC again 1 minus 4 whole square plus 5 minus of minus 1 whole square, taking the square root. Simplify, we have got it as equal to 3 root 5 units. 3 root 5 will come back here by 3 root 5. Root of 9 plus 6, that is root of 45. 45 can be written as 9 into 5. 9 into 5 inside the square root. 5 we will keep it as it is, and taking the square root of 9 we will be getting 3 outside. Therefore, root 45 is root of 9 into 5. 9, when it comes outside the square root, it becomes 3. Then we will come to AC. AC is these 2 points, 1 minus 3 whole square plus 5 minus 1 whole square, taking the square root. Simplify, we will get it as equal to root 20. How did it become 2 root 5? Root 20 is nothing but 5 into 4. 20 is 5 into 4 inside the root side. 5 I will keep it as it is. 4 when it comes outside the square root, it becomes 2. Therefore, it is 2 root 5 units. Now we will compare the distances. AB, BC and AC. AB is root 5. This is 3 root 5 and this is 2 root 5. Which two if I combine, I'll get the third one. The first one and the third one, if I add, I am getting the second one. Root 5 plus 2 root 5 gives me 3 root 5. 1 on the root 5, 2 root 5. If I add them, I'll get 3 root 5. Therefore, AB plus AC is equal to BC. Therefore, the given points are collinear. Note, we didn't get AB plus BC is equal to AC. We have got AB plus AC is equal to BC. Sum of any two must be equal to the third one. The next one. Prove that these 3 points form a right angle triangle. Again, we will write ABC, AB, BC and AC. And what did we get? Root 10, root 5 and root 5. This is not collinear because root 5 plus root 5 is 2 root 5, which is not equal to root 10. Okay. Now what should we do? We should show that it forms a right angle triangle. We have to say that Pythagoras theorem is satisfied. Therefore, we will square all the three sides. AB square is root 10 whole square, that is 10. BC square is root 5 whole square, that is 5. AC square is root 5 whole square, that is also 5. We'll get AB square is equal to BC square plus AC square. Therefore, Pythagoras theorem is satisfied, so that the points form a right angle triangle. Similarly, you can see this, check this problem. Prove that these points form an equilateral triangle. ABC is given, AB, BC and AC is found out, and all the three are equal, so that they form a equilateral triangle. And the next one, I think it will be clear to you. Show that these points form an vertices of an isosceles triangle. A, B, C is given. AB, BC and AC, they are found out. Root 34, root 34 and root 68. Two sides are equal, so that they form an isosceles triangle. Similarly, this 10th one, if A, B, C, D are the vertices of a quadrilateral, prove that A, B, C, D is a rhombus and also find its area. Recall what is a rhombus? Rhombus means it is like a kite. All sides are equal but diagonals are not equal. So A, B, C, D is being written A, B, B, C, C, D and D, N. Continuous, cyclic ಆಗಿ ಬರೆಯೋದು. A to B, B to C, C to D and D back to A. These are the four sides we'll be checking. And four sides, the distance is root 37, root 37, root 37, root 37. So four sides are equal. When four sides are equal, we have two options. Either it is a square or a rhombus. Now we should check whether it is a square or a rhombus. So that we should check what is the diagonal. So to check what is the diagonal, we'll combine alternate distances. A in the C ge, B in the D ge. A to C, the distance formula. B to D, the distance formula. AC is 2, BD is 12, therefore they are not equal. So diagonals are not equal, so that they form a rhombus. And area of rhombus is half into product of diagonals. The diagonals were 2 and 12, therefore half into 2 into 12, which gives me 12 square units. Therefore, this is the area of the rhombus. You can try these problems, parallelogram and square. The solutions of them I have attached here. Prove that it is a parallelogram. We have measured all the sides and diagonals, and opposite sides are equal, diagonals are unequal, that means it is a parallelogram. Further, we have attached the solution for finding whether it is a square. I think all of you are comfortable with distance formula now. Any queries, any questions, you can always contact me. Thank you.